Hey everyone, welcome back to WebDev Solutions. Today in this video, we learn how we can initiate or make cross-chain transactions on our own. Please note that we'll not be using any bridges to make transactions from one chain to another chain. We'll be creating our own smart contract using Solidity to make the transaction happen from a source chain to a destination chain. Okay, so especially in these days, as a blockchain developer, it's very important for you to learn how to make cross-chain transaction not through bridges but by creating smart contracts. Okay, so let's get started. So first of all, let me note what we are going to learn today. First of all, we'll see a short definition of cross-chain transaction or interoperability, you can say. After that, we'll be seeing tools and techniques which we'll be using to get the things done. Basically, we'll not be using bridges, of course. The tools, you can say, we'll see that in detail in the next slide. The tools we'll be using along with how those works, okay, so that we can get to know what are the things which will be included when we make a cross-chain transaction. Okay, after that, we'll be creating our own smart contract to initiate cross-chain transaction from one chain to other chain, and along with that, we will keep track of the transaction so that we can get to know how the transaction went through and it became a cross-chain transaction, okay, and how it communicated with the other chain. Okay, you can get to know that. So stay tuned and let's get started. Before we move on, one thing I would like to note is that no one in YouTube is essentially going this deep in creating and initiating our own cross-chain transaction. So it means a lot to me if you smash that like button to reach out this content to everyone up right there. So now let's get started. Now, what's interoperability? As you can see that word inter plus operable is nothing but how blockchains communicate with each other to get the things done. If you can see a practical definition, you can say basically a theoretical how blockchain communicate or operate with each other to modify their state, if data you can say, while ensuring the security and integrity of both the chains, which are included in the cross-chain transaction. Okay, till this day, cross-chain transaction is very vulnerable to attacks. You might have seen many attacks in this field that the bridges being hacked or due to cross-chain transaction, the funds being lost, and many more things. Okay. Now let us see the brief history of interoperability between blockchains. Okay, so we'll be just seeing just brief names of what are all the tools we had before this interoperability. Okay, so first of all, we will be having a Rainbow Bridge. We have a Rainbow Bridge to bridge assets from ETH to near, which depends on oracles and set of validators to bridge assets from ETH to near. And after that, we will be having BTC relay. BTC relay depends on Bitcoin simplified payment verification proofs to bridge asset from BTC to ETH. Basically, the transactions is nothing but SPV is nothing but a transaction verification mechanism, you can say, okay, from BTC to ETH. After that, we have a wormhole which bridges assets from one chain to another, relying on validators. Just to mention few, we have three. There are many other like IBC is there, Layer 0 is there, and many other are there. As you can see, all these are dependent on one or the other to make the transaction from one chain to another chain. So now in this video, we'll be creating our own smart contracts so that it will be more secure. I'm not saying that it is completely secure and it's not vulnerable, it's more secure. Okay, so let's move on to the next slide. So in this video, along with using our Solidity as a smart contract to write our smart contract and initiate transaction, we'll be using Zetachain. Now, what is Zetachain? Zetachain is as normal blockchain as our Ethereum, but it supports interoperability between blockchain. Basically, it allows us to initiate cross-chain transactions. You can say as simple as that. Okay, our normal blockchain with validators, smart contracts, users, transaction, all those things, along with providing a service, or you can say it provides us a functionality to initiate cross-chain transaction. Okay, now let us see how the transaction goes through from one chain to another using Zeta chain. Okay, we have two contracts, one right here in our Gorley and other right here in our Polygon, you can say. Okay, Polygon basically testnet, which is Mumbai. Okay, here in Gorley we have our Polygon smart contract, which is basically integrated with Zeta chain. By meaning Zeta chain, basically this code is being written to work with Zeta chain. There is no specific integration for Zeta chain protocol and all. Just a normal contract with specific functions which supports Zeta chain cross-chain transaction. Okay, we have our contract in Goerli. We want to transfer assets. Basically, Zeta chain has two models. One model, the first model works as sending या फिर transferring message from one chain to another chain Based on that message, the other chains states get updated. Okay, you send messages from Goerli to Polygon. By checking that message, what type of message is that? The state is updated in the Polygon chain. Okay, and the other model is omni-chain contracts. By meaning omni-chain, I mean that the chain which supports cross-chain transactions, you can say. Okay, so it has two models. Basically, one is the message passing service, and other is omni-chain smart contracts. Using only single contracts on the Zeta chain, you can modify the states of all the other chains with the Zeta chain supports. Zetachain currently supports EVM chains along with Solana as well. Okay, you can explore more that in the docs. The link will be pinned in the description. You can check that out. So let's see the transaction flow. Okay, we'll be initiating a transaction using our smart contracts in our Goerli chain. This chain, along with passing this chain, we'll be passing message, of course, as we will be using message model in this video. Along with passing message, we'll be passing zeta amount. As you might have known, we pass ethers as gas fees for validators. Same in zeta chain, we have zeta token basically as our ethers for, you can say, validators, the same as that. Along with the token amount which we want to pass, it is optional, you can say. It's not necessarily you have to pass token amount. Basically, you can pass zeta amount though. You can just pass message to make the transaction happen and the state being updated in the other chain. So first we initiate transaction in our smart contracts in Goerli, which will be observed with the Zeta observer. Observer is same as our node. Zeta chain has the observer in all the chains which it supports. These observers will be observing these cross-chain transaction. Note that how it, now you might ask how that observes this transaction specifically. It has specific things which will be included in the transaction so that it get to know that yes, this is the transaction which I have to look for. And specifically, our contract will be sending a message to another contract which is being deployed or monitored by the observer, so that when we transact from our contract to the contract being deployed by the observer, so that it get to know that this is a cross-chain transaction and I have to process it. Okay, so after it get to know that we have a transaction to be processed, it sends it to the Zeta chain core. What happens in Zetachain core is it basically verifies the authenticity of the transaction, basically whether the transaction is correct or not, and whether it implements all the things, it meets all the requirements to be a cross-chain transaction. Okay, we'll see what are the requirements though in our coding section where we code our smart contracts. It verifies basically upright here. Zeta VM is nothing but a virtual machine which is same as our Ethereum virtual machine which updates the state of smart contracts. Okay, so now it verifies the things and it sends that transaction, basically transfers, you can say, forward to TSS signer. Okay, what it does is observer observes the transaction and sends to the core. The core observes it and verifies it and it sends to the TSS signer. Now what's the TSS signer? TSS signer is nothing but threshold signature scheme signer. So here, if you can see, to send a transaction, only one person can send a transaction. Meaning, basically, one private key is called a single point of failure, you can say. To avoid that single point of failure of private key, we have threshold signature scheme. Basically, all this set of validators will be validating a transaction and initiating another transaction on the destination chain. Now we have source chain, we have Zeta chain here. This is Zeta chain, okay? This is not Goerli. This is Goerli. Up till here, it's Goerli. And we have Zeta blockchain here. As you can see, Zeta blockchain. Zeta observer will be sending transaction to Zeta blockchain using oracles or whatever we'll be seeing later in this video. Okay. After that, what it does is it forwards the transaction to TSS signer, which basically creates another transaction to the destination chain. As you can see, this is Zeta chain. Zeta chain makes another transaction on the destination chain, which we have specified in our incoming transaction up right here. In this transaction, we'll be also specifying the destination chain ID so that the Zeta TSS signer knows which chain to initiate transaction. So it initiates transactions on our Polygon. Okay. Now this is Polygon chain. This makes a transaction on Polygon chain to our smart contract. Okay. Along with passing message, which we have passed there, Zeta amount. Let's say we have passed around 2 ethers, not 2 ethers, 2 Zeta for our validation of our transaction. Let's say the validation consumption was around 1 Zeta token. Now we have 1 Zeta token left. So that Zeta token will be sent to our destination chain up right here along with initiating a transaction. Okay, as I have said, the token amount is optional, it's not necessary. Okay, and after that, here we make our transaction using our contract. This TSS signer initiates the transactions in our contract of Polygon chain. Okay, this directly makes a transaction to our Polygon chain using TSS signer. Okay, so it sends message and zeta amount, and by looking at the message, let's say I pass the message as hello. By looking at the message hello, what I have to do will be written in our smart contract of Polygon chain. Okay, let's say we have passed around. We may pass around message like transfer. We may pass around message like mint. We may pass around something else. Like based on that message, we can code our own logic in the destination chain to get the things done. So this is a transaction. This transaction is directly made to our smart contract so that we can directly make the state changes so that we don't have to use any observers in our smart contracts or anything else. It directly makes a transaction to our smart contracts where the states will be updated based on this message. Okay, so our chain with our contract make transaction, observer looks it, it goes to core and verifies it, and the transaction is verified and our zeta amount is being taken by our validators as incentive for validation, and it's been signed and made transactions on destination chain, which is Polygon, to our contract, and our contract modifies the state based on the message which it got. Okay, this is a brief overview, although we will look too closely to our transaction to know how it went through. Okay, so this is all about the tools and the technologies. Okay, so in the next part we'll be coding our own smart contract to create cross-chain transactions. So if you're interested, let's get started. So now let us code our own smart contract using Zetachain. Okay, as I've said, we'll not be coding it. As it's already available from the Zetachain documentation, we'll be using it and we'll be seeing it in detail so that we can get to know how all things work in a contract. Okay, there is no point of writing it again as it's readily available. This link will be in the description. You can just click it and come up right here. So this is a home page. We'll see in our developers. As I have mentioned before, there are two models of this Zetachain, which is the first one, omni-chain contract, where a single contract in a Zetachain maintains the state of other chain's contract. Okay, and cross-chain messaging, which we'll be using, this model we'll be using it now. And this here in this model, we'll be passing messages from one chain to another chain and modifying the state on the other chain from the source chain to destination chain. In the destination chain, we'll be modifying the state, basically the variables or the balances, what we call, using basically by watching on the one type of message which is being passed. Okay. Now in this you have to come to developers. In the developers, we'll be selecting cross-chain messaging. This is the model we are going to use. And in this, you have to go to tutorials. We'll not be watching any tutorials up right here. We'll just be taking up the code and we'll see what it does. And we'll deploy it too. And we'll come up right here. I have opened the Remix IDE. If you don't know Remix, it's just an IDE where we can easily create and deploy our Solidity smart contracts. Okay. So this is all up right here. I have created a new workspace. To create a new one, what you'll have to do is you'll have to come up right here, create new workspace. Just give it a name. Let me create a new one. Okay. CC cross transaction and click OK. The new one will be created. We'll just close it and we will create a new cctx.solve. So I'll just paste the code which we have copied from here. There is a copy option, as you can see, and we'll just close it. So first of all, we'll compile this, okay, so that our dependency separate here will be loaded. We'll compile. There will be an error for sure because our we'll click it more times. So you will have to select compiler version as 0.8.7 coming up to here, okay. Because we are using 0.8.7 up right here, by default it will be selected to 0.8.18, okay, and we'll come up right here. So this is a basic version which you can see 0.8.7 along with license specifier which we have specified MIT. This is directly from our documentation, and we have imported IERC20 interface along with the ownable interface from OpenZipline. Okay, IERC20 interface is a token standard, basically interface for token standard. If you don't know what the token standard is, we have created separate video for that. You can explore that up right here. The link will be pinned in the description. Okay, and the ownable is like kind of owner. If you want to check it even, let us check it, okay, so that we can get to know in detail. Not much, we'll just have, if you see up right here, just we'll have who will be the owner of this message, who will be the owner, and who will be interacting it, who will be interacting with it, okay. Here in this case, the deployer will be the owner. We'll not be using it much. If you can see, we haven't inherited it up right here, just imported it so that other things can use it, okay. Just kind of who will be the owner and who will be using it, just kind of you can say that access modifiers, not access modifier, kind of access modifiers will be accessing it, who has the right to access. And now the main part comes up right here, Zeta interactor and Zeta interfaces. You don't have to worry much about this. We'll see this code, or basically this file, when there is a need for it, okay. There is a need for it for sure. We'll not be seeing it directly from here, okay. We'll be seeing it when there is a need. And there is an interface which we have defined, cross-chain message errors, along with inside we have this have defined error of invalid message type, okay. And if it's seeming fast to you guys, you can just click on the settings icon and make it slower, okay. The video speed you can see, okay. And we have defined a contract called cross-chain message, which inherits from Zeta interactor and Zeta receiver, along with our interface of Zeta cross-chain message errors, okay. So these are all the inheritance which it does. We will see this these two files in detail, okay. Not now, when we explain our functions, okay. As I have said to you guys, if we come up right here, we will in architecture. If you come to architecture and click on overview, as I explained before to you guys, here as you can see, based on the message, let's say this is Gorley and this is Polygon, okay, Polygon testnet, of course. From Gorley we are gonna pass our what you can call is message to the destination chain ID, destination chain, which is Polygon. Let's say I pass hello from Gorley, it passes here and goes to Polygon, right? Based on that message hello, we will be we will already be have defined our logic based on that message. Let's say we have defined a logic like, if the message is hello, add 1,000 tokens to this user, or mint new NFT to this user. Based on that message, we'll be defining a certain logics to that message, okay. We'll see what it message and what it does and how it goes through. We have already defined the logic, which is readily provided by Zeta documentation, okay. So this is all this is just a message type. So this is a message type right here, byte32 public constant cross-chain message type. This is just a message type which we have specified here. Based on that message type, let's say I have passed this message here. Based on that message type, we'll be specifying certain logic. It's kind of, if the message type is this, do this kind of thing, okay. This is just easy to understand. If this, then do this kind of thing. And this is a single message type. You can have multiple message type. So it can be anything. You can anything you need to. We'll just specify transfer or whatever. For now, I have specified a single one, and you can specify multiple ones if you need. For just for the explanation, I have mentioned one here. Okay, and we have two events: cross-chain message event and cross-chain reverted event. Okay, and which will be taking a string parameter, as you can see, and Zeta token consumer. This will be our Uniswap interface. You can say here, as you can see, to pay for the validators, the Zeta token we have to pass the Zeta token from our source chain. Okay, from Goerli we have to pass the Zeta token so that our node validators will validate a transaction. To get that token, using within our transaction itself, we'll be using Zeta consumer, which is in Uniswap interface, where we will be swapping Zeta for ETH, or ETH to Zeta, token to Zeta, Zeta to token, and Zeta to ETH. Where this comes from? If you can see, now there is a need for Zeta interfaces. Okay, now let us go to this. Okay, once you have compiled, right, all the dependencies will be loaded from here. Okay, uh, let us just close all these things up. I'll just close everything. So in the .dps, there will be npm folder. Within that, we will see Zetachain protocol contracts, EVM. Along with that, we're using tools. So not tools, we'll be using interfaces, Zeta interface. Okay. As you can see from here, this is just a we just have defined Let's go top. Okay, we just have defined an interface. We will see this in later. For now, what we need is we need just this thing, zeta token consumer, as we have solved it. Here we just have defined events, certain events for getting zeta from either ETH or either token, and converting zeta to either ETH or to the token. Okay, and we'll just get that zeta from the ETH. We'll be calling this function for the most, because we'll be passing ethers as a fees, and that ethers will be converted to the zeta tokens. Okay, we can use all other three as well, these three as well. Okay, as liquidity is kind of whether there is a liquidity or not. Okay, it's just a just an interface. If you don't know about interface, we have made a dedicated video for interfaces as well. You can check it out in our channel. The link will be in the description. Okay, we'll go to our previous file. You can just click up right here. We'll close it. As you can see, as I have said and explained, zeta token consumer is a just an interface where we have defined certain functions to get the zeta tokens from our ethereums. Okay, ethereum from here. And zeta token is a token which we have to pass. So that here the node validators will be accepting a certain tokens, right? This address will be zeta token address up right here. So we'll be passing connector address, zeta token address, zeta consumer address. You got to know these two address. Zeta consumer address is our Uniswap address, where we'll be swapping ethers to the zeta token. Zeta token address is the token address, which is just a ERC20 token. Now what is connector address? Okay, connector, if you can see, while as I have mentioned before, in our Goerli, let's say this chain is Goerli, and here observer has deployed a contract which is a connector. So here we have to interact from our contract to the contract which the observer has deployed. Okay, the contract which the observer has deployed is called as connector. We will be sending a transaction from our Goerli to the connector contract, so that observer will always be constantly listening to that contract to check if there is any messages which I have to process, kind of thing. We'll be sending our transaction from We'll be interacting with the contract of observer, which is called connector. That's all. There is a contract called connector which is deployed by the observer, which will be interacting with from our contract in a Goerli chain. Okay, you can rewind it though if you didn't get that. Okay, and this is a zeta connector address. We'll see. There'll be You will get to know deeper while we deploy and interact with it. Okay, you'll get to know that for sure. And this is just we are just initializing it up right here in our constructor. Now let us don't see send message. We will see some interfaces and all. We'll see. As you can see, there is only three functions other than our constructor up right here. Now the thing comes from Zeta interfaces. Now let us go to Zeta interfaces. As you can see, I haven't closed it, so it's already here. We saw Zeta token consumer. We don't need that for now. Zeta common errors, as you can see, just a common error have been defined up right here. So now we'll see come from the top. Okay, Zeta interfaces. What is this interfaces for? If you can see, now let us open our send message function. We'll be interacting with this function to get the things done. I will be explaining it. Before that, if you can see, this is the structure which we have to pass as an input for the connector. What is the connector now? Connector is the contract which the observer has deployed. It's not it it may not be necessarily the observer has deployed or have to deploy. There's a contract with the observer listens to. This is called as connector. Okay. To that connector, we'll have to pass this structure as the input. What will this structure contain? It will contain a destination chain ID. So in this video, we'll be using, let me just write it up right here. Okay, we'll be using Goerli, whose chain ID is 8, not 8, it's 5. And after that, we'll be using Polygon testnet, and its chain ID is 80001. Okay, so here we'll be sending messages from Goerli to Polygon. Now let's go back to Zeta interfaces. In Zeta interfaces, right, we have Zeta destination chain ID. In this case, our destination chain ID is 80001 because it's Polygon, and Zeta chain ID destination address is the address. As you can see here in our Goerli, we are sending messages Here we don't look at this zeta part. Zeta part is handled automatically. We don't have to worry anything. From here we have to specify where we want to send the message. The message receiver will be the contract in the Polygon chain, right? So we will be specifying destination address is the contract address of Polygon chain which we have deployed. Okay. So from our Goerli, we will be specifying the contract address of the Polygon. Okay. It will be in the destination address, just kind of an address which we pass in postal address size. What is the address which we have to send this message to, kind of thing. And destination gas limit, how much gas we have to pass. This we can't uh, specify it on our own because it's already specified in the documentations. Okay, as you can see here, it's specified, we didn't saw it, and it's cross-chain messaging, and in that we have gas fees. It's specified up right here. For Goerli, we have to pass this much as gas. Here the point, we can't use point, right? So we'll be multiplying with the 18 decimals, okay? 2 into, as I have mentioned here, Ethers has a decimals of 18. So 10 into 18, which is nothing but 18 zeros after 2. The same thing which I specified here, and BSC testnet. For everything, it's almost the same, okay? Total fee is here, and the gas fee and the protocol fee is here, as you can see. So this is a gas limit which we have to specify, and the message we want to pass. As I have mentioned there, I will go back to this again. As I've said, we'll be passing a certain message from a source chain to destination chain, and based on that message, we'll be updating the state in our destination chain. Okay, that we have to pass it here. It may be hello. I might pass hello from Goerli, and it will be received by a Polygon, and the Polygon contract checks what type of message is this. Okay, this is hello. If this the message is hello, then send this much amount of ethers to someone else. We can write this kind of logic in our destination contract. Okay, we can write that, and this is all. And zeta value and gas is amount of zeta which we are passing for the validators. This is the amount of tokens which you have to pass from zeta amount, as you can see, which you have to pass, right? It's specified here how much zeta we are passing, zeta tokens. Okay, and zeta params is will not be using any. This is optional, as you can see, it's already written here to Zetachain protocol. We will not be sending any messages as a params to Zetachain protocol. So we'll be creating an empty byte stream. Okay, empty bytes. We'll see that how it works and all. And struct Zeta message. This will come. We will come to this later. This is the receiver part. Okay, and this is so. What will happen is when we now let us see our message, our send message function. After that, we'll see these two are the use cases. Okay, whether the message was successful or it was reverted, kind of thing. Before that, as I said, we have Zeta connector here. We will see from our send message function. So here in send message function, right, we are passing destination chain ID so that our observer knows to which chain I have to forward this message to. Okay, destination chain ID, in this case it will be 80001, which is our Polygon testnet chain ID, and the message which we have to pass. So the message we have already specified it up right here, as I have explained before. So this is external payable because we will be sending ethers to this function, and those ethers will be converted to Zeta tokens so that we can pay for gas. Now, whether it's valid chain ID or not. How we'll get to know whether it's a valid chain ID? If we come to a Zeta interfaces, it's not here. We will have to come to Zeta interactor, not Zeta interactor.solve. We'll have to come to this. Okay. Here it is specified is valid chain ID. What it does here, we will have to specify in this our contract, right? We will have to specify what will be the destination address and what's its chain. It's named different up right here. Interactors by chain ID is nothing but a destination address for a certain chain. Okay, we'll be setting that from set interactor by chain ID. Okay, destination chain ID in this case it will be 80001, and the contract address it's specified here as bytes, but we have to specify the contract address directly. Okay, the contract address will go here, which is the contract address of our destination chain, which is Polygon. Okay, so we are saying that for destination chain Polygon, the interactor is basically the receiver is this contract address which we have deployed in the Polygon. It will be set up right here, and the same thing is verified here in each valid chain ID. Okay, the same thing whether there is already a contract which we have already specified or not, whether we have specified a contract, basically a receiver contract which we have specified or not. The same thing it checks here. It's not which should not be 0 bytes. If it's 0 byte means that we didn't specify any contract as a receiver. Okay, 0 bytes is nothing but Kajak256 hash of 0 bytes. So now as you can see, we have checked it. So if there is no interactor specified up right here, we will be having destination chain ID. So as you can see, if there is no destination chain ID specified, there will be a reward saying that invalid destination chain ID. Okay. So as you can see, as I mentioned before, there will be a cross-chain gas of 2 ethers amount. Okay, not 2 ethers, but 2 ethers number, you can say the number which we have specified up right here. Here it will be in a kind of zeta tokens, not the ethers. Okay, and zeta value and gas, as we have seen before, it will be the zeta amount which we are passing for the validators who are sitting up right here to validate our transaction. Okay, so what we are doing up right here is zeta consumer is our NVSwap interface. From that interface we are getting zeta get zeta calling get zeta from each function. What it does is it gets the zeta tokens from the ethers which we have passed in. Okay, so usually we pass in around 0.05 ethers. Okay, 0.05 ethers we will pass in, and based on that 0.05 ethers, it will be called up right here, and we'll get certain amount of zeta tokens based on it's already, as you might have know, it's automated market maker, meaning that based on the demand and supply, it will be fluctuating. Okay, we'll get certain amount of zeta tokens from here, and which if we pass less amount of ethers up right here, if we pass 003, we'll get two less amount of zeta tokens, and our transaction will be reverted because it's not sufficient for validators to validate the transaction in such a low fees. Okay, so we have to pass around 0.05 ethers. So here, and we'll have to pass it, and we'll get the zeta token from here to this address. Basically, if you see in our zeta interactor, may not be here, it will be here. Okay, zeta token consumer is here. As you can see, get zeta from ETH. Destination chain address we will have to specify, and the amount which we want to get. Okay, amount we want to get is, as you can see, the destination address for the zeta token which you are getting is this address. Address of this means the current address of the contract, and cross-chain gas is nothing but 2 zeta tokens. Minimum amount of, as you can see, minimum amount of token which you want to get is 2 tokens, as it's specified up right here. As you can see, minimum amount is 2 tokens which we are getting up from here. So we are getting Z zeta from ETH. Destination chain is current contract address, and the minimum token amount is 2 zeta tokens. Okay, it's not in the ethers, it's in the form of zeta tokens. Okay, we'll get around this much amount of zeta tokens from here based on the ethers we have passed, and after that we will approve that to the connector. So why we are doing that? So as you can see, we will be making a transaction to our connector. So if we go to here in our architecture overview, so we'll be sending messages to the connector, and it is observed and it is sent to Zeta EVM. To be able to validate the transaction, we need Zeta tokens, right? We are just approving our Zeta tokens. Zeta token is nothing but a ERC20 token, as I mentioned before. We are approving that to the connector, so that connector can use it to send the tokens to the validators who mine the transaction. Okay, how much amount we have to specify? It will be based on the amount of zeta we get from here. Okay, just that simple. And value, as method value, is nothing but the amount of ethers we have passed. Based on that amount of ethers, we will get certain amount of tokens, as said before. Now the main part comes up right here. Connector dot send. As we have seen the send interface up right here, it's in, I think, not here. It's here. If you go up, right, as I said before, this is send input, what we have to pass to the connector. So what we are doing is connector dot send. Connector is a contract which is deployed by the observer, which you can see, as I said before. We will be sending that. Send is a function, it's a normal function in the Solidity. We will be sending that. As you can see, this is structure as I explained you before. So you come here. Okay, zeta interfaces to send input is nothing but a structure which we see here. Okay, zeta interfaces dot send input, this structure we have to pass to the connector so that it get to know all the details to send this message to. Okay, destination chain ID, as said before, interactors by chain ID is the contract address which is in the destination chain, in this case the polygon testnet. Okay, and destination gas limit is 3 lakhs, which we have specified this year. You can make this above or below even. Okay, and ab.encode message. Now this is the main part of that here. As you have seen before, based on that message in the destination chain, we will be modifying certain logic. This is important. Okay, so we'll come to CCTX all. So cross-chain message is a message type which we have to pass. In this case, this is a cross-chain message type, which is just by default it's there. So we are just directly passing it, and this is a parameter which we have to pass. Now, how will this parameter will be received? We'll be seeing that in later in the below function, which is on zeta receive. We'll see that though. Okay, ABI.encode, because we have to pass it as sketchak 256 hash, basically bytes. Okay, to convert it to byte, we will be using ABI.encode. Okay, and the first thing will be the message type, and the rest of the thing will be parameter which we want to pass in. Okay, and zeta value and gas is the amount of zeta tokens which we want to send to the validators to mine the transactions. And zeta parameters will not be sending any parameters to the zeta protocols. So there will not be anything up right here. It will be an empty bytes. Okay, as you can see up right here, ab.encode of nothing. Okay, so we are passing all the necessary details to the connector so that our message is successfully and like accurately received in our destination chain ID. So we'll be specifying everything to the connector so that our transaction goes through smooth, and it will be received from our, it will receive to our contract on destination chain ID, you can see. So we'll be doing this up right here. So this is all about send message. We pass the destination chain ID and the message. So as you can see up right here. So here, as you can see, because we are using only one message, we are specifying one message type. If you are using multiple message types, you can directly specify it here as well. Okay, you can specify it byte and memory, and you can specify like that. Okay, if you have multiple, what you can say is multiple message types. Okay, based on that message, we'll pass it up right here, and it will be received, and based on that message it will be modifying certain states of that chain. Okay, because we have only single message, I have directly hard coded it up right here. It's not coming from the parameters. Okay, and this is all. So as you can see, getting zeta and passing it and approving it and sending the details to the connector. Basically this is a transaction. This is not nothing but a transaction, as you might have known. Okay, so this is all about zeta send message function. Now now what happens when this happens? Okay, basically what happens when we send this message to the connector. Okay, we'll see that now. So now we have sent message to the connector. So now our part is done. What we have done is passing all the details. We have sent a message to the zeta connector, which is the contract which the observer is constantly looking at, so that it can get to know whether it can get to know that, like, if there is a message, so yes, I have to process transaction kind of thing. Observer will be listening it constantly. The contract will be listened by the observer. So now this is the observer part. Okay, what observer does is, as explained before, it will be sending that to the zeta core. The verification, validation, and mining, everything will be done up right here, and it will be sent to the TSS signer. Now TSS signer, here it will be signed again the transaction in the destination chain, which is our polygon testnet. Here now the transaction will be sent to the destination chain address. Now how will it get to know the destination chain address? Now the destination chain address is specified by us itself, by our we are all specifying it right here. As you can see, interactors by chain ID is nothing but the contract address of the destination chain. Okay, so this is all, and here we are passing it. You can see send message. Okay, in that we are passing it, and everything happens up right here, and our message is sent to this contract in our destination chain ID, which is polygon, as I said before. Now this function will be called by TSS signer transaction. Let me just expand this. Okay, so as you can see, this now here, right, when this TSS signer is successfully verified and our transaction got mined and everything happened, how this TSS signer will send the message to the destination chain. Now there will be certain function. There should be a certain function which our destination chain contract has, so that it gets the message which we pass from the source chain. Okay, so here on zeta message will be passed from the TSS signer. It will not be passed from here directly up right here. It will pass it from TSS signer to our destination chain contract. Okay, so what all it passes? It passes zeta interfaces of zeta message. Now what is this? If you can see zeta interfaces of zeta message we need. Okay, so it will contain, this is sent by the TSS signer. As you can see, TSS signer up right here, this is sent by TSS signer. So here it has zeta transaction sender address, which is the contract address of our source chain, and source chain ID in this case Goerli, and destination chain address is the current chain address, which is 8001 of Polygon testnet. Zeta value is the amount of zeta tokens which is left after subtracting Zetachain gas fees. Okay, as I have explained before, if you pass around 10 zeta tokens here and around 5 zeta tokens was consumed for validation and everything consensus and all, we have left 5 tokens. So now that 5 tokens will be sent in this parameter. Okay, and the message which we got. So if you can see, the byte message is the message type which we have directly. So it will be directly forwarded. If you can see, this this whole thing will be coming in this bytes message variable, basically a parameter. Okay, so this is all the data which the TSS signer passes to our contract on the destination chain. Okay, so on zeta message, here our TSS signer will pass all the data as we have seen before. So now it will check is valid message call. Okay, it will check the zeta message. Okay, as you can see, this is external, anyone can call this. Okay, so here it will check if it is verified and this transaction is sent by TSS signer, and we have the specific message type which we are expecting. Okay, so now in this case, let's say we are passing hello from the source chain of Goerli. Now the same zeta message will should be come up right here. Let's say I'm a malicious actor without any cross-chain transaction from a source chain. Let's say I call this function on zeta message. I will have to pass this thing right here. He will fail because he won't be having this much amount of data which we have right here. Okay, first of all, he will have to have a zeta value. Okay, this will not be having from his side. Okay, this will be passing from the TSS signer itself. We will not be having it. So everything will be passed from TSS signer and it's verified up right here. So is valid message call. Let us see that as well. Okay, is valid message call. It should be here somewhere. I think it's Zeta interactor. Okay, as you can see, is valid message call. So it will check if it's a valid caller. Okay, now what is valid caller up right here? It's in our, I think it's in our Zeta interactor errors. Okay, is valid caller will be in our connector. Okay, connector is the contract. It will specify the caller address up right here. Okay, whether it's a verified caller. Verified caller is our verified verified caller is our TSS signer. Okay, sorry for that. And it will check for that whether TSS signer has sent this message, and after that it will check whether sender address is our contract address of the source chain, and it is specified by us itself. Okay, we have to specify our contract address in both the chains. Okay, here we will in the Goerli chain, right, we will specify our interactor as the contract address of the Polygon chain. In the Polygon chain we will set the interactor as contract address of the Goerli chain, vice versa you can think of. Okay, so here it verifies if the condition doesn't meet, it will revert it there itself. Okay, what will happen in revert, we'll see that as well. So now let us go back to our function of on zeta message. Okay, this will be call from TSS signer, and it will verify it so that no malicious actors will be coming in between and making everything upside down. Okay, so here we will take the message type as I have mentioned before. Based on the message type, we will be specifying, we'll be like doing certain transaction after maintaining certain logic so that our state gets updated from the cross-chain transaction. Okay. Now here we'll have to code a bit thing. Okay. So this will just decode our thing from this thing. Zeta dot message is nothing but our message. As you can see, zeta dot message is this message which we pass in. Now we just have to decode it. Okay, there is a specific function called abi.decode from which we will get our every data which we have passed from our source chain. Okay, and we have to specify the type. Okay, and now after that we have decoded everything which we need. This is a message and the message type. Now, if the message type is not this, meaning that we don't, someone is calling this function with unknown message type. Let's say we have message type specified as transfer and mint in our destination source chain ID. Okay, in source chain we have specified uh, the message type as transfer and mint. If someone calls this function other with a message type other than mint and transfer, it will be reverted. Just the same check. It shouldn't be other than the message type that we have. If we have more than one message, we will just have another AND condition, logical AND condition, saying that message type not equal to the another message type which we have. Okay, the same thing. And based on that, we will revert it and we'll emit things such as like cross-chain message event. Now in this case, based on that message, we are not doing anything. Okay. Now we will do something. So we'll have if condition, if message type equal to cross-chain chain message. What we will do is we will have certain we will define certain things, basically code logic. Okay. I will just create another event. Okay. Event, this is message type 1 of string. String is our message which will be passing from on zeta send message. Okay, this message we will be emitting it upright here. So let us make it capital. It's not printed though, just a standard following. Okay, and as you can see inside this we'll have complex logic. For now I just have specified a simple logic. We'll emit another event called this is message type 1 of message. As you can see, if the message type is this, as I said before, if the message type is transfer, we will be transferring something to someone based on the parameters we have. Here the parameter is just a message. You can specify multiple parameters in here itself. Okay. You'll be specifying one by one here. After the message, you will put another comma and you specify another parameter up right here. So for now, we'll just passing one parameter. Okay. So we'll close this up. And if you can see, if the message is this type, we'll do something up right here. This will be complex logic. For now I have specified simple one, and you will have another as well. If the message type is any other type, let's say if the message type is some other type which you will be having for sure, but for now I'll be having just one, so I'll be specifying just one if condition. Okay, if condition is not mandatory. If you have to perform certain logic based on the message, you will be using if conditions. Okay, and we'll be having cross-chain message event. Based on that message, it will be coming in the parameters of this event. Okay, this is all about on zeta message. So as I was, I'll just give a brief everything before we are talked about. Okay, so as you can see, this is zeta message which we called from our TSS signer to our destination contract. Okay, with passing all the data which we have specified in send message function. So now let us close this. Now let us see on zeta revert function. Okay, so now let us expand this and let us see when this function will be called. Okay, so as I mentioned before, as you can see, when you send some less amount of tokens, let's say you sent around 2 zeta tokens for the validation, but the validation requires 3 zeta tokens, there will be an error up right here in the transaction which we have sent. So it will be reverted from here and the connector will call this function. Okay, as the same scenario, the connector will send the call this function of our contract up right here on zeta revert, specifying that this message was reverted. And as you can see, zeta interfaces dot zeta revert and zeta revert everything what we have specified in the send message, right? Everything will be passed up right here, the same thing. If we see, right, I'll just close it here, and what we all get in zeta revert call. Okay, we will see it. Okay, on zeta revert, right, the same zeta revert message will be passed up right here. Now from where this will get from, okay, from here we'll see this, the same thing as I explored before, the same thing up right here. Okay, here everything where our gas fees will not be refunded. Okay, it will be deducted, and after that it will send back our the tokens which we have left with. Okay, and as you can see, the same thing, the source chain ID, destination address, destination chain ID, remaining zeta value, and the message which we have passed, the same thing which will come up right here. And the same thing we are looking whether it's a valid revert call, which is as I said before, whether it's called by a certain contract of a Zetachain. Okay, just a verification as I said before. It's here as well. We call is okay, is valid zero invalid. Okay, this is just an error. We have something up right here. Okay, yeah. As you can see, on Zeta revert is specified in Zeta receiver interface, which is in Zeta interfaces.sol. Okay, so we have this function which will be called from here. Okay, we are implementing that up right here. So we'll be calling that isValid revert call function from our Zeta interactor. IsValid revert call, basically checking whether it's a valid reverter. Basically our connector, what you can see, and Zeta transaction address, blah blah, everything will be written here as I said before here. And in the cctx.sol, right, we'll come back again, come back here, and we will, after the validation, we will decode the data. And let's say we have a message type up right here. So we will be decoding it. In this case, we will be passing message type as cross-chain transaction, as I have said before up right here, cross-chain message type. Okay, cross-chain message type. So we'll get that. Let's say what we have did is here we want to transfer uh, one thing. I'll just close this. I'll just open it. Okay. Let's say we have a complex logic up right here. So what we do is, let's say if the condition is if message type, let's say if message type. Now the message type is not coming from parameter. Assume that the message type is coming from parameter is equal to double equal to cross-chain message. What we might have, I'm just giving an example. Okay, what we will doing, let's say we have to transfer our tokens from one chain to another chain. What we will do is we will burn it from here, right? Let's say token dot burn from. So there is no function called burn from though. We are just I just have given a scenario. Okay, let's say now we are burning from the sender address so that we will mint it on the other chain. What will happen is, here we have successfully burned it and sent our message. In this scenario, let's say our transaction validation failed on the Zeta chain. Now what will happen is, this burned amount is up right here. We can't get it back, right? Here we will burn it. We can't get it back. So what we will do is, on Zeta revert, we will code a certain logic. Like if the revert message, if message type message type is equal to cross chain message type. Okay, if this is the message type, meaning that we have burnt it up right here on the send message function. If the transaction is reverted, what we will do is we will just mint it back, mint to token dot mint to kind of thing, you can say token dot mint to and address. Okay, this kind of thing will be there. Okay, basically a scenario which you can think of why Zeta revert is important. Okay, the same scenario as you can think of, and we are checking it whether the valid message type is there here and all, and we are just emitting a cross chain revert event. So this is all about what this contract does. Okay, so we have send message function on Zeta message, which will be called by our TSS signer. So send message function we will be calling it to the observer contract. Okay, basically the connector contract, and on Zeta message will be called to our destination chain contract from a TSS signer, and on Zeta revert will be called to the source contract. Okay, not the destination contract. Let's say we pass it from the pass something from source contract and it reverted. The revert function will be called directly from the source contract itself. The observer calls Zeta revert function. Okay, it will not call in the destination chain. Okay, it will be called to the source chain itself. So these are the three functions. Now let us see how the let us deploy this, right? Okay, first let us deploy this, and let us make a cross-chain transaction and see how it actually works. Okay, so now let us deploy these contracts on the both the chains which we have specified before, the Goerli and the Polygon, and see how this works. Okay, so as you can see from Goerli we are sending messages to the Polygon. That doesn't mean that you can't send messages from Polygon to Goerli with the same setup, right? You will be calling send message function in the Polygon, and it will be received in the Goerli as I have specified the logic as before. Okay, The same thing, you can specify any chain which Zetachain supports. You can check that in their white paper, which is specified in their docs. There's direct link in the nav bar, and we'll see up right here. So now let us deploy this, okay? So let us just compile this back again. So there is some error on the line 78. So as you can see, I don't have this type. That's my mistake. So what I'll do is I'll just cross-chain message type. If I now compile it, right? It should be compiled. Yeah, it's compiled. Okay. So this is how you can make this, and this was my mistake. Sorry for that. And now let's move on. So if you don't have Goerli, right, what you can do is you can just come up right here, and what you can do is Goerli. You can just go to gorleyfaucet.com if you have the mainnet balance of ethers. You can directly get that. If not, you will just go to Goerli proof of work. What you'll have to do is you'll have to mine. Here you will not be eventually mining something. Here it will be running some logics to get you the ethers. Okay. What I'll do is I just show how you can get that. Just a bonus tip you can think of. I'll just put my password. So what you will do is I have got around 2.5 ethers from the proof of work faucet itself before I didn't had it. So what you'll have to do is just copy your address, paste it here, and there will be a captcha, and you will have to specify like click. I have to specify cast though. That I have to do all these things in Windows itself. So start mining. What it will do is it will just perform something for some time, and it will provide based go leads for certain amount on based on the hours and the hash rate which you have. Okay. As you can see, based on this, you will have to like you will get the Gorley ethers directly. Okay, you will get it. I'll show the transaction itself. I got around 2.5 and even more from this Ethereum. So I just show the transaction activities, and it's not okay. As you can see, this 1 ethers and this point 0.3, point 0.1, and even point 0.4, point 0.1, and point 0.1 ethers. Everything is come from here itself. Okay, you can just get the print here. So you just have to click on stop mining, and everything will be here. There will be a claim button called here. It will be clear. Once you click it, you will just get the Gorley ethers. Okay, as the Gorley ethers is kind of unavailable most of the times, okay, merely. And what we'll do is you will have to click on injected provider. If you have MetaMask or something else, you will just click up right here. Your browser wallet will be coming up right here. We'll be using MetaMask though. If you don't have it, and just install it, you can just get it easily. Okay, we have to ethers balance. Now the question is where we will get these addresses, these parameter addresses. There is a solution. It's not a solution, it's directly applied here for us. What you'll have to do is you will have to come to tools. Here you have to click on testnet as we are deploying it on the testnet. Okay. Here everything is specified for us. Okay. So we'll be using not 8 minute, we'll be using Goerli testnet, right? Here everything is specified for us. Here there is a connector address. We'll just copy it. As you can see, here we are in tools, testnet, and we just have to scroll it. I will get Goerli testnet, and we have to copy connector address because we have to pass it up right here. So we'll pass it, and after that we'll need Zeta token for our consensus mechanism. We'll paste it right here, Zeta token, and Zeta consumer address is our Uniswap interface. As you can see, Zeta consumer Uniswap version 2. Okay, you'll just have to copy it and paste it. So we'll have to transact it. Okay, so let's wait for the transaction. We'll just go through step by step, okay, so that you can clearly get to know. So we'll just confirm our transaction. So it will be deployed for now. And what we'll do is, it's come up right here. We will just switch to Polygon because we are deploying another contract on the Polygon chain. Okay, so we will open up our MetaMask, switch to Polygon from here. Here we have Polygon up right here, Polygon Mumbai. Click on this. I have around 1 Matic something, yeah, 1.9 Matics. You can just directly get it from maticfaucet.com. Okay, maticfaucet.com. Matic. Okay, sorry, it's Mumbai Faucet. MumbaiFaucet.com. You can just come up right here and you can get around one Matic token for free. Okay, as you can see, one Mumbai token. Mumbai Matic is basically testnet Matic. So I just have switched it. As you can see, it's 80001, our Polygon chain ID, which is of testnet. So we will deploy it, okay? And let us just remove all this, okay? And so that there won't be any errors. So now we want Mumbai testnet. We will copy the connector address from Mumbai testnet. We will paste it right here and token of Mumbai testnet up right here, and we'll copy that from here right here, and then Zeta token consumer uni v3. Basically the address what we saw, right? Get Zeta from ethers here. It uses this address to get Zeta for us. Okay, we will just transact it. So pops up. Confirm the transaction, and as you can see, it's taking around 0 cents. Let's confirm. As the multiplies is low to around $0.50, maybe. Yeah. And as I said before, we'll have to set the interactor for both the chains. Okay. We'll come back to the same picture which we'll be using for all the video. Yeah. So now we have the second one here right here, right? This is our Polygon one as I have deployed it second. Okay. So this is our polygons this thing. So one thing I have missed is I have missed the message up right here. So I should have made it public. It's publicly. Just a minute. Chain message. Yeah, this is the message type which you have to pass. Okay. So first of all, before everything, we will have to set the interactor as I said before. So on the Polygon chain, our Goerli chain's contract will be the interactor. So what we will do is, as you can see, it is set interactors by chain ID function is there. We have to pass the chain ID as 5 because we are setting our contract in the Goerli chain. We'll have to pass the contract address, just copy it from here. You don't have to convert it to bytes and all. It's already in bytes. And passing it here, just click on transact. Okay. So our MetaMask pops up right here. Yeah. And we'll set the interactor as our contract of the Goerli chain. Okay. In the Goerli chain, now we have to set the interactor as our contract, which is on the Polygon chain. So our transaction is confirmed. So now let us switch to Goerli and make our transaction again. Okay. So I'll come to MetaMask and switch to Goerli and set our interactor as the contract address which is on Polygon. I just switch it so that it comes up right here. We don't need to deploy it again. So now it should be 5. Yeah, it switched as you can see. So what we'll do is we will close this. This is so to verify, right, whether you are on the correct chain. Okay. Now I am in the Goerli chain. To verify it, whether you are on the Goerli chain or Polygon chain, you just have to click any function, right? If it returns the default output, now let us open this, right? Okay. And here it should return though. No, it's not returning. So that we already know that. So now let us open this cross-chain message from for our Goerli, which is in our Goerli chain. We will just copy the message, basically the address of our contract in the Polygon chain, and we will set it up right here. So the chain ID will be 80001 and our contract address will be. So click transact. Our Goerli transaction will be coming up right here. And what we'll do is we'll just confirm and we'll just send the transaction and we'll see how the transaction goes through. And it's costing us around 19 cents. Okay. Okay, now let us call cross-chain message. Okay. So now what we'll do is we will copy the message type. This is the message type. As you can see, this is cross-chain message type. Okay, we will copy this. We will open send message. As you can see, this red, it means that it's payable function. And message, okay, we are directly passing the message type. We don't have to specify it. As you can see, it's hard coded message type, so we don't need any message type to pass. So we will pass hello there, hello there, and the destination chain ID will be polygon, right? So what we'll do is 80001. So now it will, as said before, it will check it's a valid chain ID or not, and everything will be set up right here based on the ethers which we pass. Now how do we pass ethers? We'll have to come to ethconverter.com, I would say. Okay. So now what you'll have to do is you will just I'm just using is to get the amount of ethers which you want to send. Okay, I just send 0.08 ethers. I just copy it. So you'll have to come to ethconverter.com, as you can see up right here. So every link will be there in our description. You can just click from there. So I just paste it up right here. And what we will do is in our send message function, as it's payable, I am passing 0.8 ethers because I have up right here 0.08 ethers though. And along with that, I am passing a message 80001 and hello there. From now, we are passing message from Goerli to Polygon. Now let us click on transact. Now everything will be specified, and from our ethers, right, our Zeta tokens will be coming. I will let you let you see how it works and what have happened. We'll just confirm it, and let us go to Goerli scan and see how the transaction went through. Okay, so this is a message call which we have done. So this should be confirmed. It might take a bit more time because it's payable. Okay, it's done. We just copy the transaction hash, copy it, and Goerli etherscan.io. This is our like default etherscan explorer by our etherscan team. We will just paste the transaction hash. So this is done from our contract to this address. So as you can see, this is a transaction hash which we got from our here in our what you can see is a command line. You can say not a command line, basically output window you can think of. So what it does is it basically takes that 0.8 ethers from here and calling that Uniswap interface and Uniswap functions and all. What it does is first it converts ethers to wrapped ether and wrapped ether to the Zeta token, and that Zeta token will be sent to someone else. Okay, so someone else in this case is our connector. Okay, so what it does is took that ether and converted it to Zeta and send it to our observer. Observer sends it to our Zeta VM so that the validators will get that Zeta tokens to validate the transaction. Okay, everything happens up right here, as you can see from here to here. So now what you can do is explorer.zetachain.com. You can come up right here. So here in the cross-chain transaction section, right, you can get to know about your transaction. It is kind of too late. Like it updates a bit late, as you can think. It's too speed even, but not that speed as we can think of as our Goerli. Okay, so our Goerli transaction, everything happens up right here. Now what is happening actually is observer has already listened this. Now observer will send this transaction to Zeta Core chain. Zeta Core chain transaction will be up right here. Now if we refresh, right, it might be here. Sometimes it's too late, even it takes around minutes. Okay, as you can see, our transaction came up right here. If you want to confirm its EVers, what you can do is if you just click on it, right, you can see your address up right here, your externally owned account address. And what you can see is if you have to verify, you can see the amount of Zeta you have. Okay, if you can see the amount of Zeta we sent here is 48.6, and the amount of Zeta which it has here is 48.6. Okay, as you can see, this is how you can verify that it's your transaction. Okay, so now let us actually see whether our transaction gone through the Polygon and it's successfully done or not. Okay, so we'll check in our contract address. So it's not verified, but the events will be there for sure. So the events are not yet emitted, meaning that the transaction is not yet sent from our Zetachain. Okay, it might take around 5 minutes, and average it will take around 5, or minimum it will take around 2 to 3 minutes. Okay, so here as I said before, our transaction went through, observer observed it and listened the contract and verified the transaction, and Zeta VM has verified our transaction, and validators done all the validations, and now the TSS signer has sent the transaction to a source chain, which is Polygon. Now the transaction has to come to Polygon, and it have to verify. Okay, it will be verified from our Polygon consensus and all, and after that we will get the chain, basically the contract, basically the logic will be executed when the TSS signer calls on Zeta message function. Okay, if you can see, as I have explained before, on Zeta message will be called by TSS signer. Okay, so we will close this, we don't need it back. Okay, for now at the least, just refresh to see if our transaction gone through. Okay, so as you can see, our transaction successfully received on the destination chain, which is contract address of Polygon testnet. So we sent our transaction from Goerli testnet, and as you can see, we got that thing from in the testnet of Polygon. Okay, on receive function, as you can see, on receive function here, there is an event which is emitted when the onZeta message is called. Okay, so this event is here. You'll have to come to events tab of contract address. Okay, so as you can see, cross chain message event is passed, basically being emitted. So where is that event? Here, as you can see, the event is here. Okay, so the message we passed is, if you just come up right here, it is hello there, I think so. As you can see, hello there is being passed, and if you just convert the, as you can see, the third parameter is hello there, and if you convert it to text, as you can see, hello there is there. Based on this hello there, we could have defined complex logic to execute certain things when there is a Crosschain transaction happening. As I give an example of token transfers, right? The same thing, you have complex logic, and when this event, basically this message is being basically being called, we can have certain logic to be executed. As you can see, we have successfully made a cross-chain transaction by coding our own smart contract using this. Okay. So now we have made a transaction from our Goerli to Polygon testnet. Okay, as you can see. So what you can do is, you can eventually send the same message from the Polygon to the Goerli as well by calling the send message function from our Polygon to Goerli. We will not be doing that. You can test it out right here. Okay, just we have to pass a chain ID as 5, because Goerli is our chain destination chain, and the message which you want to pass in, and based on that message, we'll be doing certain logics. Note that these two contract threads. Now in this case, we have the same contracts. That doesn't need that like it doesn't need to be same on the both chains. Okay. The basic requirement which we have is, these three functions should be there. Okay. These three functions should be there to be able to make cross-chain transactions. Okay. And this, both the contracts doesn't have to be same. They might be different on both the chains. Okay. Goerli might have different implementation, and Polygon might have different. Okay. And one thing you have to note, as I said before, in Goerli, right, we pass around 0.08 ethers to get the Zeta tokens, right? In Polygon, you will have to pass around 5 to 6 Matics, because the Matic price is too low. So because of which, you'll have to pass around many Matics to be able to send a transaction from cross-chain transaction from Polygon testnet to Goerli testnet. Okay, so this is all in this video. So let me know if you have any single doubt. You can get it though in the transaction explorer or either Zeta documentation. You will get everything up right here. And if you have any questions, even a single one, don't keep it. You will just ping it out in our comment section, so that we can get to know about your doubt and we can figure it out eventually. Okay. And one thing I'd like to ask is, if there is anything which you want improvements in this video, might be the video is too speedy, or might be a bit more explanation is needed, or bit less explanation is needed, everything or anything which you want to say to us, you can just put it out in comments. We'll make sure that it will be implemented in our next video, and in our, let us see. And if the video was helpful, make sure to like and subscribe this video and share this video with one person which you think it will be valuable for. Okay, being a blockchain developer, it's valuable for everyone. And now we are grateful for knowing that you can create a transaction from one chain to another chain, coding your own smart contracts. So this is all about this video, and make sure to subscribe and like the video. Thank you all. Bye bye. See you in the next one.